At its Freiburg plant, SolarWorld produces multicrystalline silicon wafers for the photovoltaic industry in accordance with the highest quality standards. The preliminary products for solar cells are manufactured in 4 almost fully automated production processes: crystallization, brick production, wafer fabrication, and wafer finishing. Ultra-pure silicon is used as the base material in the manufacture of multicrystalline wafers. The feedstock is placed into a mold made of fused quartz. With a load of up to 600 kilograms of silicon, the mold starts out on its way toward melting furnaces. The fully automated process maintains the highest purity standards and conditions. With crystallization furnace temperatures reaching more than 1,400 degrees Celsius, the silicon melts within 20 hours. After 3 days, we have produced a multicrystalline silicon ingot measuring 84 by 84 centimeters. The efficiency of the subsequent solar cells depends entirely on the quality of both the melt and the crystal structure. Upon removal from the mold, the silicon ingot is transported from the crystallization center to the ingot store. While continuing to cool, it remains in an intermediate buffer zone, awaiting further processing. The crystallized silicon ingot is then removed from the ingot store and hoisted into a so-called bricketer. This high-tech machine divides the ingot into 25 equal-sized square bricks in a cutting process which, owing to silicon's special material structure, poses a unique challenge to the tools involved in this process. A view inside the bricketer shows a cutting head with numerous deflection rollers, over which a special wire runs. The arrangement of the rollers ensures that the wire saw produces a matrix corresponding to the cross-section of the bricks. The cutting head slowly sinks downwards, causing the wire saw to cut through the silicon ingot. With rapid to and fro movements, the slurry, which consists of a mixture of silicon carbide and polyethylene glycol specially developed for the silicon cutting process, is kept in motion. The cutting process, during which the silicon ingot is cut into 25 bricks and side parts, so-called tops and tails, are removed, takes approximately 7 hours. Then it's time for a wash. Fully automated computer-controlled conveyor lines transport the cut ingot pieces to the ingot washing system. This latest generation cleaning system resembles an oversized dishwasher. First, high-pressure jets blow a cleaning fluid around the silicon ingot. A blower subsequently dries the bricks. 15 minutes later, a robot picks up the bricks one by one, measures their geometric parameters, and passes them on for marking. High-tech measurement devices weigh and measure the silicon bricks and scan them using infrared rays to determine the quality of the silicon crystals. Short and efficient routes, these are the defining features of our water production workflow. As soon as the bricks are catalogued, a fully automated shelving system transports them into the intermediate store. The storage location is chosen such that bricks of the same quality are stored together. The system also combines varying brick lengths to form a uniform machine size, a so-called batch. Following a thorough sorting of the bricks, they are now ready for the next processing stage. Via the fully automatic shelving system, the pre-sorted silicon bricks are then transferred to the wafer fabrication stage. The bricks are bonded to both a glass plate and a carrier panel, a technology that has been developed and continually improved by SolarWorld's experts. In the wire saw section, which comes right after the bonding center, another wire saw process is used to cut the bricks into thin discs, the so-called wafers. The high-tech saw is equipped with 2 large track rollers. In contrast to the bricketer, a special wire of roughly 700 kilometers length runs across it at high speed, creating a rotating wire field through which the silicon bricks are pushed. The wire transports slurry. Its fine particles slice the silicon brick into wafers that are approximately just 0.2 of a millimeter thick. After approximately 8 hours, the plant has produced between 2,000 and 3,000 wafers. As one of the largest photovoltaic companies, SolarWorld not only produces wafers for its own solar cell production, but also for sales to customers worldwide. The fourth and last production stage in the manufacture of multicrystalline silicon wafers begins in a large cleaning plant. The sliced bricks, which are bonded to carrier panels, are pre-cleaned in baths to remove all slurry and saw residue. The plant then automatically transfers the bricks to an adhesive removal basin, where the bricks are separated from the carrier panel, resulting in approximately 0.2 mm thin silicon wafers. Next, the wafers are isolated and run through further cleaning lines, various surfactant and water baths, and the subsequent drying process ensure optimum surface cleaning. All wafers are then measured by fully automated sensors and cameras and graded according to their thickness and surface quality. As base elements in solar cell production, multicrystalline wafers are subject to very thorough final inspections. Aside from automatic testing procedures, the trained eyes of our staff also help ensure the high-quality standard of our products. Finally, once they correspond to all our strict quality requirements, the wafers qualify for the SolarWorld logo. Securely packed, our wafers are then shipped all around the world. Again, automated processes guarantee maximum punctuality and flexibility. In as little as 8 days, ultra-pure silicon has been transformed into multicrystalline wafers for the photovoltaic industry, applying fast, energy-efficient, and cost-effective processes around the clock. Each day, wafers with a total capacity of around 1.5 megawatts leave the factory, enough to cover the electricity requirement of 1,600 people and take another big step along the way towards worldwide, independent, environmentally friendly, and secure energy supplies. This is what we at SolarWorld stand for. We turn sunlight into electricity.